Hope you're doing good. So welcome to session on artificial intelligence. So why artificial intelligence? Why machine learning? Why neural networks? Why deep learning? Why do we have hear so much? Why do we hear these buzzwords a lot these days? What is the reason it became so popular post 2010? So it was just that researchers in AI and machine learning and even in deep learning that was going on, that started way back in 1960s. but but what uh, but what happened was that most of the researchers were theoretical, and we didn't have infrastructure, we didn't have that compute capabilities that we could actually go ahead and solve problems or do computations at that scale. It was only in the beginning of this decade that we had that power. We have acquired those capabilities that we are able to crunch a lot of GBs of data, because way back in 1960s, even a 5 MB hard drive used to, just for rent use, it used to be $2,000 of that time. So yes, now we since we have those compute capabilities, it's very much feasible, and it's actually a natural interest that everyone had, that okay, let's try to solve this we already the tech community or the researchers, they had their interest rekindled after we gathered all these capabilities. And obviously the applications like voice recognition, or you have searches, you have you have some image classification, or there are plethora of applications which are out there. So yeah, that's one reason why artificial intelligence became so popular, and why we are talking about it today. So particularly that was I was actually before this I was working into traditional software, then moved to big data, and then it was gradual transition for me. So yeah, that's how I got interested into artificial intelligence. So okay, let's get started with the first. Let's get started with some definition, that is what is machine learning, and then since the nature of course is going to be most of hands-on, so then we'll dive straight into examples and solving some problems. So most of the course will focus on machine learning and deep learning, and that's pretty much all you need in artificial intelligence today. But yes, obviously, if there are a few other important areas as well, which I'll try to cover in coming sessions. So yeah, so uh, Tom Michel, from CMU, he defines machine learning as if an algorithm which is performing a task T with a performance P, and if its performance increases with its experience, then that algorithm can be said to implement machine learning. That is, means if your algorithm is becoming better with experience, that is, if it's performing more examples and it becomes better at performance, then then that algorithm can classify as a machine learning algorithm. So yes, so let's and one yeah and one more important thing is that one more important virtue machine learning algorithms should have, that it shouldn't need to be rewritten if you have some certain rules. Let's say we have a system wherein we want to classify, wherein a bank wants to classify if they have to give loan to a certain user or not, to a certain customer or not. So okay, what do? They might have some historical data, and previously what they used to do was they had a set of questions like, what is the record history, has the person been able to repay loan, what's the debts he have. So questions like these, so they were hand coded written rules. But when we are doing machine learning, we no longer need these rules. All we need is to have some data and let the machine learning or machine learn from the data, or let algorithm optimize itself, let it align itself to so as to be able to give us the desired output. So it will means whatever I am speaking right now, it will make much more concrete sense when we dive into examples. So yes, so when we are dealing with well today for doing hands-on, there are few famous libraries. If you are not very much well versed with Python, I would suggest it's pretty easy to learn Python. I'll post good resources to learn Python in description. But however, I think it should be able to you should be able to do that. Okay, now, so the way we are going to do is there are few famous libraries which I would like which I will be using when we are covering hands-on on machine learning. So those libraries are scikit, learn, and TensorFlow. Yep. So these libraries, I'll come back to this. So, but this is just for just for hands-on whatever we are going to do. So, let's say how is how how is a machine learning problem different from a traditional problem? So let's say if I ask you to write some program which just computes something. Let's say you have to compute a factorial of a very big number and give stipulated time. Maybe you have a very good algorithm for that. But what if I give you a problem? Okay, write a program for classifying orange, for differentiating between apples and oranges. So what would you do? Okay, so one approach can be that, okay, if I have an orange, I will try to see, okay, how does it looks. I'll say, okay, I'll do some pixel analysis on it. I'll check what is the color of it, what is the size of it. Maybe I can list down all features. So basically what this approach is doing is that it is writing the rules, and if some object classifies or satisfies those rules, we will say that, okay, this object is orange, or this object is an apple. So yeah, but what happens if I give you a black and white object? What happens if I give you which does not complies with any of your rules? Maybe I just give you a banana, I ask what is it. So yeah, in those cases we need to know that we might not be able to, means whatever be your exhaustive list of rules, means however exhaustively you can write those rules, but you will never be able to classify everything or cover everything in the universe. There will always be something I can come up with and say, hey, your rule does not cover this. So in those cases, then comes machine learning to our rescue. So yeah, so this is a classic example wherein you have to classify between apples and oranges. This is a very famous example. It is like hello world of machine learning. So if you have to classify between apples and oranges, let's say what I can do is, let's say we have some data, okay, and let's say I have some data like weight, texture, and table. And I say if it is bumpy, and let's say I call it an orange. Similarly, I have some data and the texture is smooth. I call it an apple. Okay. And the problem statement is now for us that I want to be able to classify that if I have a data set or if I have a data point, I should be able to judge and say that, okay, whether is it an apple or is it an orange. So okay, let's say what do we do for a typical problem like this? So we can have something known as classifier. So classifier is something, let's say right now we can take it as a some sort of rule box or example. Okay, let's observe the data. If I were to plot this, how will I plot? Let's say I will plot it on a line somewhere like this, and I have, let's say I'll just plot the texture here and I plot the weight here. Okay, and let's say I call this texture smooth at this place. Sorry, let's call this texture as smooth, and let's say we call it double. Similarly, if I were to just plot the data here, what, let's say on y-axis we have weight which is increasing on the y-axis. So let's say smooth, and so apple, it should come somewhere like this because it is 130 and 140. And let's say if you have an orange, it might land up somewhere here 170 and 150. Yeah, but let's see this here. Yeah, now if we observe closely, what is yeah, if we observe closely, we have two very distinct set of data. That is, maybe there is an imaginary line which passes here, passes through this graph, which will be able to classify that this data, that it will be able to classify that apples are different from oranges. Or there can be some rule which says, okay, whatever falls in this cluster is an apple, or whatever falls in this another cluster, is an orange. So there can be ample of opportunities. So let's say for now, to solve these type of problems, we will need machine learning. So for hands-on, let's say if I want to develop something, so all it takes is some 5 to 6 line in scikit learn to be able to implement this. Obviously we'll learn about the maths behind it and how it actually functions in sessions which we'll cover later, but all it takes is 5 to 6 lines to be able to represent that, to be able to solve this problem to be able to solve this problem, or to be able to write this problem which just classifies apples from oranges. So next what we'll do is I'll show you the code and then we'll see how does it looks like. So yeah, and the library which I'm going to use is scikit-learn again, and feel free, if you have any doubts you can contact me, or you can post in comments and I'll help you out if you have some problems with setup or anything else like that. So library we'll use is sklearn, and then let's check out the implementation.
Yeah, okay. So let's have a look at the example wherein we try to write a classifier which is able to classify between apples and oranges. So if we want, we can have a look at the data we have. It's a very simple data. We just have 4 data points, and based on this, we are writing a classifier which is able to classify apples from oranges. So this is a program like it's hello world of your it's hello world of your machine learning. It's a very basic program. So what I have done is I have uh, what I have done. So these columns, they are called features. So for example, weight and texture is a feature, and label is something which is the unintended output. So this is a form of supervised learning wherein you have a defined output, and based on the given inputs you have a well defined outputs. There are other techniques where you don't have a defined output, and so we will come to it. We'll cover that later. So that would be covered in unsupervised learning. But if we have something, we know what's the output for us. So that means that's a good case for supervised learning. So what we have done here is now uh, I have just I have just plotted these the values of features in a two-dimensional array. So as you can see, what I have done is I have assigned value 1 to smooth and bumpy is equals to 0. So because I at this moment I won't be able to do anything with the text data. I don't My algorithm won't understand what is bumpy and smooth. So to be able to classify that, what we have done is we are assigning a numerical value to it. So what do we need to do is now if we see we have features 140 comma 1. So you have weight and texture. So yeah, similarly you have 130 comma 1. So and corresponding to that, I have classified apple with I have labeled apple with a 0 and orange with a 1. So we have features vector here and then we have labels here, so that is pretty straightforward. Now, what do we do here is now we have a tree, and we have a tree. We have imported tree from sklearn. This is from scikit-learn library. So we are going to often use scikit-learn library. So it is a part, and this library is available in Python, and it has a whole lot of supported APIs and classes which can be used directly for machine learning algorithms. Though we will look into classifiers sometime later in future sessions, but for right now, you can assume that it's a black box which is able to give you some answers. So let's say if we were to, if we were, suppose we could have a look at the data. So what would we do? It was like we can just say, okay, 140, 150 and bumpy means anything which is after 150, maybe above 150 is, and if it's a bumpy, we could call it an orange. So, so this is like you can understand it as a black box, which is an intelligent black box. So what we have done here now, we are now fitting our features and labels here. That is like it will try to find that pattern in it. So that is basically learning. That it is learning on the given data. Next, what you do is next we need to test it. So for testing, what we have done is now we want it to predict 160 comma 0. 160 is a is weight somewhere between 150 and 170, and 0 is represent bumpy is represented by a 0. So the answer should be oranges for it. Yeah. So what we'll do is we'll now try to run this program and then let's see how does it looks like. So yeah, we have here, yeah. So this is a simple Python program I'm writing, and then here I have decision tree Python. So it will take a couple of seconds to learn, and then yeah, the output it has given me is 1. That is 1 was represented by orange. So yep, it's your we were able to write a mini classifier which separates apples from oranges with uh, with some 5 to 6 line of code. Now if you want, we can try it with some other values. Let's say if it was 1 comma 0. Obviously if we have pretty inconsistent data, it might not be able to predict correctly, but yes, let's try with some of this data. Oops, shouldn't give me 1. Okay. I got the problem. The problem is actually I was editing another instance of the file here, so sorry for that. So I'm running from here. So let's edit this and we should be able, we can expect that it should give you an output that is an apple. Yeah. So it gives you an output that is 0. So that's how it's working. Yeah. So yeah, we are able to do a hello world program. And now what you can find all the code. I will write this in description, and so that you are able to download this and do hands-on. So for this you need basic just a Python installation. After that, in future sessions, we'll cover the installation of Jupyter Notebooks, Anaconda. So these are basically IDEs and supporting frameworks to be able for you to be able to write machine learning programs. Yeah. Let's move on to the next section then.
This problem which we have seen in that we had we sort of we tried to collect that data whatever we had in raw form. We tried to identify the features, we tried to identify the labels, and then we sort of played around and we implemented our algorithm, and then we were able to make some good predictions on that. So this is collect data, train classifier, and make predictions. So this is the normal workflow which will work in most of your cases, which will work in most of your cases in machine learning. So yeah, so without further much ado, what we can do is we saw something called as decision tree classifier in the previous example. So how about now we'll try to visualize how those decisions are made. Actually, we will try and see how that decision was made. So for this, we'll try to use a data set that is called iris flower data set. This data set is actually so famous that it is even integrated in scikit learn library. So if you can, I have posted the link for this data set in description. It is readily available. So what we are going to do is now this earlier we had seen a very simple problem where we had only 4 line, very few data points, and where we had some clear demarcations. So what we can do is now, let's say we take a let's say we let's take a little more complex data where you have iris flower and you deal with its petal. So flower can have, so now if you have a flower, now we are classifying the features of that flower as petal width, petal length, sepal width, sepal length. Let's say now these are my 4 features, and what I want to do is that I want to be able to understand how decision tree classifier actually works. Let's say I had a flower, I had some dimensions given it to it. Some I'm just putting some random values here. We will be able to see these things in much more detail when we see the actual value and when we'll do hands-on on that. So let's say now you have some features, and there are 3 varieties of iris flowers. Those are Virginica, setosa, yeah, and yeah. Okay, so Virginica, setosa, or I think versicolor, yeah. Virginica, setosa, and versicolor. So these are three types or 3 categories of iris flowers. And what the problem statement is, now you have a data of iris flower, and now we should be able to, now if you have another data coming in, we should be able to go ahead and we should be able to predict that, okay, this data is okay, this is the new data and this is how I can classify that as. So yes, let's check out the implementation, and the implementation is going to be little bit it's going to be pretty similar to the previous one. However, we will be able to visualize that decision tree and actually see how those decisions were made.
Let's have a look at iris flower dataset, and we will what we will do is we'll try to actually write a program which is able to classify the 3 types of iris flower. This dataset was originally compiled by biologist Ronald Fisher. He was writing a paper wherein he wanted to use those the multiple measurements to be able to uh, discriminate between the type of iris flowers. So let's have a so these are the flowers on the right hand side, if you can see, and on the left hand side we have related data. So let's say these are the features again. If from the first example, we already know that we have some understanding how do we identify features and labels. So sepal length, sepal width, petal length, and petal width are features, and species is the label. So basically, we see uh, there are some data points for setosa, followed by versicolor, and followed by virginica. So we need to now write a program which reads this data set, and later it is trained on this data set, and later if we give it any new later we will be able to test, or when we give it a new data point, it will be able to classify that. So the let's have a look at the program. So yeah, so again we have imported scikit-learn, and scikit-learn from scikit-learn we have imported load iris. So iris dataset is so famous that that has been imported into scikit-learn library itself. So but when you're writing a real life program, so at that time what you will need to do, maybe you'll need to import it from CSV or some gz file, or from some other, if any other source. So first what this program does is it just prints all the feature names and target names. So what are the features and targets, and then later it tries to print the first row from the data. Now, later what we have done is, now this is something called what we are doing is that when we're trying to train the data. Let's divide the data into some training set and test set. So what's the benefit is that once I have trained my algorithm on the training set, I should I can go ahead and be able to. I'm confident. I should be. It should confidently be able to predict whatever I have classified in the test set. That is, if I had 100 rows, and let's say I don't learn on all the 100 rows, I just learn on some 90 rows. So obviously, it should be able to predict the other the output of other 10 rows. By output, I mean the labels of other 10 rows. Okay. So what it is done now, let's say right now we have decided, let's change it to 50 and 100 right now. I'll let you know why, and then we'll check back what happens for 11 and 10. So these are just the indices of the data points for indices of the data points. For example, this would be a 0. So similarly, it would be starting from here, we will have some data points. So yeah, so roughly we can see 0 would be a setosa, 50 is a versicolor. If you want, you can copy this and put it in a Excel file, and maybe you can, if you are really interested in knowing the row ID. But yeah, safely we can say from here. I mean, I have already verified it. So what happens is that 0 is setosa, 50 is versicolor, and 100 at 100th index somewhere we would have a virginica. Okay, so we have now deleted the test data from our training set, and now let's do is let's train that. So this is pretty similar to the previous example which we have had, right? Now once we have done it, so we will need to verify. Now this is the test target, that is, this is something we had expected. Okay, so for corresponding to 0, 50, and 100, I expect it to give me output as setosa, versicolor, and virginica. So their corresponding indices are 0, 1, and 2, respectively. So yeah, and later we would see what is the result that is produced that is predicted after learning. And in the last section, what I've done is we have used scikit-learn's string.io method, string.io and py.dot. So why? So as to be able to print a graph, or the workflow, what the algorithm has used to be able to predict. So we are now going to print the model itself, the model which algorithm uses for making the predictions. So let's run the program, and then we'll see how it looks like. Okay, so we will have, now let's run the program, Python, and Yeah. So what we have seen is first line gives me all the features, and second line is the target target name. So Setosa, versicolor, and virginica. And this is the since we have two instances, we have printed that. So okay, this is the data point and corresponding to Setosa. So first line of the data set. Secondly, now these two lines 0, 1, 2 and 0, 1, 2 are the points from here. From here, when we have tried to print the test target, and next we were checking that what is the predicted value. Okay, so what we can do is now let's go, and it should have created a graph for me. So here it has been created, so we can go ahead and check what is the model it was following. So yeah, we can see it has now what it has done is it has learned on the data, and then it has done some predictions, and it has identified few boundary values. And after that, whenever it picks up a new data, it will run this model. That is, it will ask some question on the data point, given data points. Is the petal width lesser than zero point 0.8? And if it is yes, then it will straight away go to Setosa, or no, then it has another series of questions. So that is, it will be able to identify uh, it will be able to identify to what class does that data point belongs to. Yeah. So let's do one more thing. We can have another run. So let's do that run. Yeah. So let's why I'm deleting is because when in the next time it will try to write this PDF, it might give me an error. So that's why I'm deleting it. So anyways, let's do this. Let's take some other values. Okay. Let's take 75, and let's say I take a 10. So the expected output should be somewhere around let's see. It should be somewhere around, maybe it should be 0, 2, 0 or something like that. Maybe let's just have a look. So 0, 1, 0. Okay. So 50, 0, 1, 0. That is like one would be for versicolor. So that's okay. Okay, we can try a few more data. Like let's take something. Now it should give me an output of which is all setosas, right? So yeah, we can do that. And I've not deleted that iris, so iris PDF. So maybe you might end up getting an error, but anyways, we'll be able to get to know the predictions at least. So yeah, it is 0 to 0. Yeah. So similarly, we can go ahead and we can try those values. So maybe it has overridden that. But yeah. Okay. So that's all for today's session. So let me know how you feel about this, and how you feel about it. And yep, thank you so much, guys.